Today, we're diving into Stepflow, the brand new open source protocol and runtime for orchestrating AI workflows. It's new, it's different, and this can be really big. Remember when Model Context Protocol came out and every developer was rethinking how they build tools? Well, it's happening again, but this time with your entire AI workflows. Have you ever tried to orchestrate a complex generative AI workflow and change together some multiple steps, something that involves different programming languages, agent frameworks, remote APIs, and different tools, moving data between different models, data stores, and processing steps? That sounds familiar. This is exactly the type of problem Stepflow is built to solve, with a promise of modular, performant, secure, and interoperable workflow. Make sure to watch till the end because you will learn exactly what Stepflow is, where it came from, why it's a big deal, and why you should care. I will share real examples of running Stepflow, where Stepflow shines compared to other orchestrators, and show you how its design might be a game changer for your AI strategy. Let's start with the basics. Stepflow makes it simple to build secure, reliable, and portable generative AI workflows. It is an open protocol and runtime built by longtime contributors to Apache Cassandra and Apache Beam and open sourced by IBM under Apache 2.0 license. Think of it as a cross between workflow engine and a toolkit for connecting AI components. So what does this look like? Let me give you a quick mental picture. In Stepflow, a workflow is a declarative YAML file with three parts: the input schema, the steps, and the output. Each step references a component, like a Python function or a remote tool, along with instructions on where to get its inputs, from the workflow input from a previous step, and how to name its outputs. The runtime reads this file, it spins up each component in isolation, it passes data between them, collects the results. Because it's YAML, it's easy to generate, version, and share, and you don't have to know Python or Go just to define your workflow. Stepflow takes care of running it, handling concurrency, passing data between the steps, dealing with errors, and untrusted code isolation for you. If your workflow fails halfway through, Stepflow journals all intermediate results so you can resume from where you left off. When you need to call a tool written in another language, you simply point Stepflow to that component through its open protocol and you're done. So why is Stepflow a big deal? Stepflow brings some unique features that set it apart. It is an open protocol. Components talk to Stepflow runtime through JSON RPC over standard output or HTTP, which means you can write your components in any language. A Rust service works, a Python script works, an external tool implementing MCP works. Everything is interoperable through a standard interface. AI tooling is extremely fragmented, and open protocol that provides interoperability is a big deal. It provides per-step isolation. Each workflow step runs in its own process or container. Why should you care about that? Because AI workflows often run untrusted or resource-intensive code. You know that people increasingly run MCP servers or open source projects that haven't been written by them. And if you're pulling in a community-contributed scraper or a third-party parser, you don't want that code to crash your entire pipeline, abuse your resources. If it crashes or leaks memory, only that step fails. So Stepflow can retry or skip it based on your error handling rules. This isolation also allows you to set resource limits, so one step doesn't take up the whole CPU or memory in a shared environment. Stepflow has built-in content addressable storage. So whenever your steps produce data, model outputs, intermediate results, or files, Stepflow stores it in a blob store identified by a hash. This means the same input produces the same blob ID, enabling automatic deduplication and easy reuse. If your workflow fails and you restart it, Stepflow can pick it up right where it left off, with all intermediate data already available, so no extra caching layer needed. It is declarative by design. Workflows are specified in YAML. Sounds simple, but declarative definitions are powerful. You can version them in Git, you can generate them programmatically, let an AI agent build a flow on the fly, and they're easy to understand. Input goes here, component A runs, its output goes to component B, then we produce result C, and there is no hidden logic. Everything is described upfront. Before I show you how to run Stepflow, let me also paint a few scenarios where these features are not just nice, but critical. Imagine you have a multi-language pipeline. You need to process a batch of documents. First, you run a service that performs high-performance embedding. Then you hand those embeddings to another script that clusters them. Finally, you call an API, like an OpenAI API or Anthropic API, to summarize each cluster. In a typical orchestrator, you would write 3 tasks in Python or call out to REST through the container and handle API calls manually. In Stepflow, you define the steps in YAML, you point each step at its component in Rust or Python or Java, and the runtime orchestrates everything through this unified protocol. Data flows automatically between steps, regardless of the language or host. Now, imagine your workflow uses a third-party component to get data from a website and parse the HTML. If that component is buggy or malicious, it could leak credentials or bring down your process. And because Stepflow runs each component in a sandbox process with strict resource limits, a bad actor can't break your pipeline. The worst that happens is that if this step fails, you can catch the error and decide whether to retry or skip. It helps with untrusted plugin isolation. Now, a very common scenario, a generative AI pipeline that can take hours. It first downloads a large document or documents, then chunking, embedding, multiple calls to an LLM, and halfway through your server crashes. On restart, Stepflow looks at its journal, the blob store, and picks up from the last successful step. So you don't redo the work that has already happened. If you try doing that with a plain workflow tool, you will end up writing your own state store. Another interesting area of potential is agentic workflows. Because Stepflow workflows are just data, you can let an LLM agent build or modify them. An AI assistant can decide which tools to invoke, assemble a YAML flow, and ask Stepflow to run it. That's a different level of automation compared to code-centric orchestrators that require Python or other language to define tasks. At this point, you might be wondering who created Stepflow. So this is why I'm personally excited about it. I've been into the world of distributed protocols and distributed systems for more than a decade. And if you're like me, you know of a company called DataStax. And you may know of a certain large-scale database called Apache Cassandra. You may also know of the Apache Beam project to help with batch and streaming data processing. And if you look at GitHub, the people who open sourced Stepflow are the people who contributed heavily to Apache Cassandra and Apache Beam. So they are incredibly brilliant. They know the ins and outs of complex systems and elegant solutions. And here's where it gets even more interesting. DataStax was acquired by IBM. So technically, IBM just presented us with this new open source protocol and runtime called Stepflow. IBM has been very public about their ambition in generative AI, especially around the Watson X platform. My personal opinion is that Stepflow, as an open protocol, an extensible, interoperable, and secure workflow engine, is huge for their leadership in AI. IBM already serves large enterprises that care about security, isolation, and regulatory compliance. Stepflow's per-step sandboxing and content addressable storage, durability align perfectly with some of those needs. And if we combine that with IBM's deep investment in open standards like Model Context Protocol and Agent Communication Protocol, it's a really strong foundation for building secure, interoperable AI pipelines. If Stepflow becomes the de facto standard for AI orchestration, it will be a huge win for IBM, not just for using it internally, but by influencing the entire ecosystem. Now, let's see how to run a sample Stepflow workflow. In this setup, there is a Python script, Langchain server.py, that starts a Stepflow server. Inside that script, we define functions like text analyzer to calculate word counts and other text metrics, sentiment classifier to give you a simple positive, negative, or neutral score, and math operations to perform some basic arithmetic. Each of those functions returns a LangChain runnable, and by decorating them with server.langchain component, we register them so Stepflow knows about them. It's as if you're introducing those 3 mini services to Stepflow and giving each one a name: text analyzer, sentiment classifier, and math operations. On the Stepflow side, there is a YAML file called decoratedrunnable.yaml that tells the runtime what to do. It expects a single piece of input, the text you want to analyze, and it has 3 steps. Call the text analyzer, call the sentiment classifier, and run the math operations. Each step references the component by its name. Stepflow takes care of sending out our input to the right function and collecting the results. The output is structured with separate fields for the text metrics, the sentiment, and the math results. There is also a configuration file that points Stepflow to the LangChain server and tells it to use those decorated components if they exist. To see it in action, we run the workflow using the Stepflow CLI. We provide an input, like this is a great example of LangChain integration with Stepflow. We'll get back a JSON response showing the word count, character count, and sentiment of positive with a confidence score and results of adding, multiplying, and raising 2 numbers to a power. With this approach, reusable LangChain components behave just like any other Stepflow step. You write them once, you register them with a decorator, and then orchestrate them declaratively in YAML. All right, let's dive into the OpenAI example inside the Stepflow repository with the OpenAI Chat Completion API. This example uses Stepflow's built-in OpenAI component to talk to ChatGPT. The goal is simple: send a user's question along with an optional system message to the OpenAI API and return the assistant's response. Before you run this example, you need 2 things: an OpenAI API key in the Stepflow CLI built from the repository. You can set your API key in your environment. The example defines its input in a small JSON file, input.json. It contains 2 fields, prompt and system message. The prompt is the user's question. In this case, explain quantum computing in simple terms. And system message gives the assistant context, telling it to act as a helpful expert who explains complex topics to beginners. Next comes the workflow definition itself, OpenAI chat.yaml. It defines an input schema requiring a prompt and allowing an optional system message. This schema ensures the inputs are of the type string and even sets a default value for system message. The first step is called Create Messages, which takes the system message and prompt from the workflow input. It packages them into an array of messages the OpenAI expects. Notice the $ from expressions in the YAML. They tell Stepflow where to pull the data from, either from the workflow input or from a previous step. Stepflow automatically passes the right values to each component. The second step, Send Message, uses the built-in OpenAI component. It receives the messages produced by Create Messages and calls the OpenAI Chat API. Finally, the workflow's output section maps the response from the send message step to a field called response. When the workflow finishes, you will get the assistant's reply as structured data. There is also a Stepflow config.yaml file, which tells Stepflow how to locate components. In this example, it routes everything to the built-in plugin, since both create messages and OpenAI are included in the built-in component library. To run the workflow, we use the cargo run command, indicating the flow, input, and config files. Stepflow reads our YAML flow, it sets up each component in its own process, passes our prompt and system message, calls the OpenAI API, and returns the assistant's response. If you need to integrate other steps, say fetch data from a database or perform post-processing, you can add more components to YAML. So how is Stepflow different from Airflow, Perfect, Temporal, or Argo? These tools are incredible at orchestrating traditional data pipelines, but they weren't designed specifically for generative AI workflows. You can force them into the AI world with plugins or specialized SDKs, but you'll have to handle a lot of glue, especially if your components are written in different languages or if you need sandboxed execution. So Stepflow is brand new, but I see a ton of potential. For me, it's one of the most intriguing AI infrastructure projects I've seen in a while. I am excited because Stepflow addresses problems that general-purpose orchestrators weren't designed for. It treats AI components as first-class citizens. It embraces language independence. It prioritizes security and durability. And it's being released at a time when the industry desperately needs more innovation, common open standards, and interoperability. So my recommendation, if you need to integrate multiple tools, run untrusted code, or build pipelines that can resume after failure, then Stepflow is really worth looking at. And if you are at an enterprise thinking about AI governance and scalability, pay close attention to that, because this can be really the missing piece. And if you have questions, add them here or send them to me on LinkedIn. I would love to hear what you think. Make sure to like this video and subscribe to my channel. Thanks for watching, and I will see you in the next video.
Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.